Welcome to the third Pixinsight tutorial. In this tutorial we're going to look at color combination, which is for mono images, and then image solving, which is important for the final process that we'll look at, which is color calibration. I hope you find it useful. So we're going to combine mono RGB filter sets. We're then going to solve the image so that it has an accurate astrometric solution. This accurate solution is necessary for the new color calibration tools which Pixinsight has introduced in the last year. These new tools are photometric and spectrophotometric color calibration. Now, channel combination is used to obtain an RGB image from mono images. So you would have a red, green and blue integrated image for each of the red, green and blue channels. The process can be found under Process, Channel Management, Channel Combination. It's a fairly simple process to use. It's necessary to assign the correct coloured filter to its appropriate colour channel, and then you click the blue circle to apply. This process can also be used for a basic Hubble palette narrowband image if you have hydrogen alpha, sulfur and oxygen integrated images. Go to Process, Color Management, Channel Combination. Here's the process box. It has a box for each of the red, green and blue images, and they are the three integrated images we have on the left hand side. Now there are two ways to load the images into the appropriate box. One is to click the little folder icon, go down and choose the appropriate image, in this case the red, and then click OK. We're not going to do that one, there's an easier way. You basically go across, you pick the image identifier box and you drag it to the appropriate channel. When you get the plus, you release it and that's loaded the image. So we do this for each of the red, green and blue channels. Again, tick the Inherit Astrometric Solution and click on the blue circle. We now have an RGB image. You can see the image by hitting the STF Auto Stretch button. There's our colour image. That completes the process. We will now move on to image solving to provide the image with an accurate astrometric solution. The script processes are found next to the process on the menu, and you go to Script, Image Analysis, Image Solver. Color calibration requires an accurate astrometric solution as it uses the colours or the spectrum of the stars contained in the Gaia database. If your image doesn't have any data inside the boxes you'll see in a moment, then you can do a search, enter the target name, and then it will fill in the necessary data. You also need to enter the equipment data as required and then click OK to execute. Script, Image Analysis, Image Solver. You can see here that my image, due to my FITS header, has most of the required data. Again, if it doesn't, use the search button and enter the name of the object. Also, you need to fill in the image scale with the focal distance of the telescope and the resolution. You don't need to alter the parameters, and then execute with the OK button. You can now see the process working through the database against the stars that it's detected to solve the image. If you don't use this process, quite often the colour calibration will fail and then you'll need to go back and do it. So it's always good to do it for each of your integrated images that you want to calibrate. The process is finished and the astrometric solution has been written into the file. We now move on to photometric colour calibration. This is not the latest, but it's quite a new tool, and it basically corrects the colours of the image based on photometric data that's been collected by the Gaia survey. The process can be found under Process, Colour Calibration, Photometric Calibration. As I said before, this requires a detailed astrometric solution which we carried out with the image solver script. It uses a remote database, so you need to be connected to the internet to get the data on the photometric star colours. If you don't have an internet connection, you need to then download the databases. You can go to the Pixinsight download site where you can get the files, and there's detailed instructions of how and where to download them to and to get them working on your system. This process gives a good balanced colour image of the target. Here I will demonstrate the process. We go to Process, Colour Calibration, Photometric Colour Calibration. Here's the process window. Leave the white balance set at average spiral galaxy. There are very few, if any, changes you need to make. The catalogue search, you can see, says automatic. That will connect to the internet and get the data that's required based on the solution to the image. You can change that to your to the database on your computer if you've downloaded that. There's no need to change the background neutralization, and to make the process operate, you pick the blue triangle, click on it, drag it, and drop it onto the image. Don't worry about that, I just wanted you to be able to see the process console. And there the process is complete. On the right you can see there is a graph showing where the stars sit against the white balance on the image, and that's a very neat solution. Close the process and you can now see we've got a very nice colour balanced image with a neutral background, and you can see that there are definitely colours within the galaxy. Once that's carried out, then go to the image identifier box. I usually change it to RGB PCC, so when I save it I know where I am. You must put an underscore instead of a space. An alternative colour calibration, and this is the latest version that Pixinsight have released, is a spectrophotometric colour calibration, and this corrects the colours in the image based on the spectrum of stars. The process can be found under Process, Colour Calibration, Spectrophotometric Calibration. Again, it requires a detailed astrometric solution that we provided with the image solver. The database can be downloaded from the Pixinsight download site where full instructions are provided. The process gives an accurate, balanced colour image of the target. It can fail. It claims it can't find enough samples. If that does happen, there's very little you can do, and the fallback is to use photometric colour calibration. Here's an image of the process console. It is quite a lot more complicated than photometric, and there are more inputs that are required. So you'll see the white reference again leave as average spiral galaxy. You then need to choose a QE curve. If you click on the little down arrow, it has a large number of sensors listed. I think there are 6 or 7 Sony sensors. If your sensor's not there, just go with the ideal QE curve. So here I've chosen my sensor, which is the Sony IMX183, and basically I'm looking at it as a one-shot color camera because I have the one-shot color version of this. For the one-shot color, you can use the default because once you pick the sensor, it puts in the correct UV IR cut filter for that sensor. The catalogue is the Gaia DR3 SP. You don't need to alter background neutralization, and then you drag the triangle to the image, release it to execute. I'll now demonstrate this process. So we take the average spiral galaxy, leave that as it is, choose the sensor. You can see here that there are quite a number of sensors are included. I think there are now more available on the internet. Choose your filters as necessary. If you're doing mono, you can choose the manufacturer of the filter and obviously the colour. And once you've done that, you can leave all the other defaults. Take the new instance triangle, drag it to your image and release. The process will then take place. So that's the end of this third tutorial. The linear processing, you will be glad to hear, is now complete. And in the next tutorial, we'll demonstrate stretching the image where I will look at 3 alternative methods for different kinds of images, one for a galaxy and one for a nebula. And I hope you've enjoyed this tutorial and you've been able to learn something from it.